Hello friends, welcome to Electronics Engineering Exclusive. Today we will discuss the part 3 of the measurement subject, that is random error analysis. So let's start. Basically the analysis of random error is done by statistical analysis because the number of values under the measurement are very large. We take large number of reading then analyze the data. So that is done by statistical method. So after compensating for all the systematic error, if large number of readings are taken for a given value of parameter under measurement, then it is observed that the various reading will scatter around a central value. So as you can see in the plot that there is a central value and all other readings is scattered around that central value, either closely, either widely. So a plot between the parameter under measurement on the x-axis and the number of reading on the y-axis is known as the histogram or frequency distribution. So this graph which you see on your screen is the histogram or frequency distribution curve. Now the extent by which the readings scatter around the central value is known as dispersion, which is an indicator of precision. So higher the dispersion, lower will be the precision, and if dispersion is lower, then precision is high, as you can see directly by the graph. Now there are some standard terms in statistical analysis in which mostly we know. First is arithmetic mean. Everybody knows the formula of the arithmetic mean. Second is a range. Range can be defined as the difference between the maximum and the minimum value of that reading. So that will be called range. If we talk about the average range of the error, we have to just divide it by 2. Now we define the deviation. Deviation is defined as the departure of the reading from its arithmetic mean. So how much the value is deviated from its arithmetic mean is given by the deviation. The simple formula is to just subtract that reading from the mean value. Now the most important is precision in the nth reading. It can be calculated by dividing the deviation by its arithmetic mean. Now let's talk about the average deviation. The average deviation is defined as the sum of absolute value of all the deviation divided by the total number of readings. As you can see directly by the formula, the average deviation is basically indicator of the precision, as we have already shown by the histogram curve. It is inversely proportional. If we increase the deviation, the precision will be lower. If the deviation is lowered, precision will be more. Now the formula of standard deviation is given by this. The standard deviation is defined as a root of sum of all the deviations squared divided by total number of reading. You have to square the deviation, sum them and divide with the number of readings. If n is greater than 20, then we have to take n, and if n is less than 20, then we have to divide it by n minus 20. This is convention. Now let's talk about variance and standard deviation in the combination of quantities. When various combining quantities are given, then how to find variance and standard deviation? This is the most important part in the analysis of random quantities. So in this, let x is a function of x1, x2 and up to xn, and vx1, vx2 up to vxn are the variance, individual variance. So if you wish to find the resultant variance, then we have to use this formula. We have to take partial derivative of x with respect to x1, then square it and multiply it with the respective variance, and we have to sum up like this up to n. If we wish to find the standard deviation, then we have to take the root. So this is the formula of standard deviation, and since standard deviation can be defined in terms of individual standard deviation also, because vx1 will be sigma x1 square. So we have to just replace vx1 by this, vx2 by this, and we get resultant standard deviation in terms of individual standard deviation. So now let's talk about uncertainty analysis. As per the definition, if the deviation of the measured value from the true value is specified in a single or unisample of data, either in terms of degree of confidence of the user or the odds against which the measurement was taken, then such a deviation is called uncertainty. It is basically the confidence of the user, because we are uncertain in that data. We have to take the information from the user to define it. So it is basically an uncertainty. The formula for uncertainty is similar to that we have found in standard deviation, but we have to just replace standard deviation with uncertainty, and individual standard deviation with individual uncertainty. So let's solve an example on this. Two resistors R1 and R2 are connected in series. The value of these resistance are R1 is equals to 100 plus minus 0.1 ohm and R2 50 plus minus 0.03 ohm. Find absolute uncertainty. The resultant value, that is capital R, is equals to R1 plus R2 because they are connected in series. And if we partially differentiate capital R, that is R1 plus R2 with R1, then we will get 1. So here is 1. And again, if capital R, that is R1 plus R2, is differentiated with respect to R2, then again we get 1. So this is 1. And uncertainty is given in terms of error. So omega R1 is equals to 0.1 and omega R2 is equals to 0.03. You have to just substitute the value and calculate the uncertainty. Next, we will discuss about classification of instrument. Please like, share and comment on this video, and if you want regular notification from our channel, then subscribe our channel now. Please suggest us the ways by which we can make more informative videos. Thanks for watching.